whichever one of these I passed first, which is the eyeball. The 0th curve in the eyeball has an intersection at the parameter value of this. And the 3rd curve in the eyeball has an intersection at the parameter value of this. Seems reasonable, I guess. There must be a way to get a curve at an index. Surely Grant has implemented that. Nope. Or maybe add curve, subdivide curve, get nth curve, points, get subcurve. What is a subcurve? Yeah. It has this assertion, which I don't know if I like that, but this is gonna get the number of points per curve, then do get points at points per curve times n up to, you know, this thing. Is this for regular or OpenGL? It's for OpenGL too. Okay. So let me try to rederive these intersections by using the index and the value of the parameter. So I should do for curve index and t-value. T-values in intersection t-values. And just print them at first. Now just print these. Okay, so that's good. That's what I want. I can say for t-value in t-values intersection point equals. And now here, I'm also going to need a way to evaluate a cubic Bezier or a quadratic Bezier curve, which I also don't know if it's in here. There's something to... There has to be code to evaluate a cubic Bezier curve in here somewhere. Right? Right. Where would it be? Space ops or something? It's like a def quadratic something. Guess not. I'm gonna look in space ops. Yeah, there's nothing here. Man. That's fine. I guess it's not that hard to do anyway. Bezier curves are at least 4 points right. It can be anything from 2 or more. But if it's 2, then it's just a line. Yeah. I think it can even be 1, but if it's 1, then it's a point. But the ones that Manum uses when you use OpenGL have 3. Okay, so before I get the intersection point, I'm going to have to get the curve. So I'm going to say curve equals, and in this case, it's the eyeball. I have to get nth curve. Oh, there's a get nth curve function. Maybe that's what I want. Oh yeah, and there's this Bezier function. So oh yeah, and there's this Bezier function. So I can say get nth curve function. And what does Bezier do? This returns a callable. Interesting. So I want this at curve index evaluated at p-value. And that should give the intersection point. And then I'm going to put a dot there. And then I'm not going to do this. And with luck, nope, that didn't work. It should be called like that. Nice, and it still works. Only let me make these smaller again. O.03. I actually think I want 4. Okay, so what that means is that I can now find the values of the parameter at which these intersections occur. So this should give me a way to cut off this ellipse. Although now that I think of it, man, this is getting more and more annoying. I'm going to want the indices of the curves and the parameter values for both of these objects, the ellipse and the eyelid. So this alone isn't enough. Man. So now what I'm probably going to end up doing is returning 2 lists. Where was I throwing out? Somewhere around here I was just throwing one of these out. Here. Here is only taking the 0 index. So now I'm going to take both the indices. So I do this. This gives me the t values for the first curve in the first row, then the t values for the second curve in the second row. T values at size greater than 0. So here I'll just do at 0 to size greater than 0. Then I'll do that. So I'm going to do that just to make sure I didn't break anything. I want to make sure every step here is correct. And now what I want to do is also index this at 1 for the second curve. And then now I'll call this curve 1 t values. And I have a curve 2 t values. Curve 2. This will be index 1. I feel like the math could be simplified, maybe seems very low level, so that's parametric. The math for what? What I would have liked to happen is this would have been a lot easier if there was a simple way to find the intersections of two Bezier curves. Turns out there's not. The general way to find the intersections of two Bezier curves. Turns out there's not. The general way to find the intersections of two Bezier curves is like a recursive function, and it's not analytic. It's only a numerical approximation, which is just so annoying. Okay, so I'll return this. Let me index this at 0, and everything should work in the same way. Perfect. I'm literally doing all of this. All of this work is for tracking an eye movement for the geometry you're doing by hand. I'm not doing a ton of geometry by hand, actually. I'm doing a lot of coding, for sure, to pass around the data in the proper way. But most of the geometry is being done by this library. It's like when I do this curve1, no, not this. This curve1.intersect, this is doing pretty much all of the geometry work. Pretty much. What was I doing now? Object intersection t value. So I have this. And I did this for 0. I'm going to try incrementing this to 1. This should now be tracking the eyelid, not the ellipse. Then I'm not going to use the eyeball here. I'm going to use the eye.eyelid. And try doing the exact same thing. Hopefully this will look the same. And it does. Okay. So math works. That's nice. Now what I need to do is construct an ellipse. Not the right term. There is a ton of passing around data. That is happening quite a lot around here. Okay, so now what I'm going to do is construct a mobject whose bottom matches this ellipse and whose top matches this eyelid. And that's probably going to require de Castelnau. Probably. And if I have... Yeah, I don't think there's a way to do it without de Castelnau or whatever. It'd be really nice if I had the parameter value for the mobject rather than the curve. But I don't. Although, I know, actually, the more I think about it, I know that there's code to do this. There's no way there isn't. To like get a point from a curve index and then a parameter index into that curve, it has to be here somewhere. Does point from proportion do it? Point from proportion does do it. It's getting the number of curves. It's finding this residue. So it's finding a curve index. Yeah, this is doing exactly that. Hold on. So let me find I'm gonna decrement this back to 0. So now it's indexing into the ellipse. Run that again. Nope, broke it. What did I do? Eyeball. And now I'm going to say now what should I call this? I'm just gonna call it mob. But I'm gonna make this, I'm going to say now what should I call this? I'm just gonna call it mob. But I'm gonna make this the eyeball.copy. And then I'm gonna have to do the opposite of this. I'm gonna have to get proportion from point, basically. Which I bet that's not a thing. Yeah, it's not. Um, so I don't want point from proportion. I think I want pointwise become partial. So for this, if I... This is sort of a weird function. If I have the points A and B, then I can call pointwise become partial on maybe an empty object, and the V object can be the eyeball. Jeez, this is complicated. It's basically getting the lower index and the lower residue, then the upper index and residue, which I already have. Then it's creating this object. It's getting new points. And then what I assume this is doing is filling in the new points into the um the copied V object. Then it returns self. What does it do to self? Or just says self.setPoints. Okay, so what I might be able to do is say mob equals just OpenGL VMobject. Then do mob.pointwise. Ah, but this doesn't take the residues. Is there like a mask? No, there isn't, unfortunately. Actually, even if there was, it wouldn't be that great because it's possible. Well, unless the mask had like an ability to cover things that were above or like above a certain line, then that would work. But if I had to have an object up here, then I would have to manage like the height of that, which I wouldn't want to do. I wonder where the extra... Is this adding more dots than usual? That's what I was thinking. Yeah, it would actually be pretty nice to have masking functionality, but it doesn't have it by default. Yeah, that would be nice. It looks like there's actually 4 dots in this. Are there 4 of these? Wait, what'd I do? There are 4 of them. which isn't what I expected. Why did that happen? The eyeball and the eyelid, intersection t values at 0. I need to print intersection t values at 0. 0, this, and this. 3, this, and this. 0, this, and this. 3, this, and this. Wait, why are there 2 of these? Then like one of the pairs is off. That could be a problem. I think this came up from when I switched this to returning both indices. T values at oh, this should be at 0. This should be at 1, right? T values at 0, that size 0. Then I pin that index and then the values at 0. Okay, so I think this is right. And that prevents that duplication. Great. Okay, so where was I? Mob equals OpenGL Vim object. I think what I'm going to end up doing is like copying pointwise become partial. But is even that what I need to do? Low tuple equals this, high tuple equals this. This is probably more efficient. Okay, so I'm going to copy this. And then I'm going to put it probably in here, which this function is getting really crowded now. Remove the self variable. Change vmobject to, I guess, just mobject. Oh my gosh, everything's broken on the new Vim version. This will be mob2, and then just everything, all the Vim objects are going to be mob2. Then all the selfs, it's going to become mob1. Okay, so now I have the pointwise become partial function. Oh man, there's this integer interpolate I have to bring over too. Oh wait, no I don't. Because I want this to take the residues instead. So I'm gonna say, I'll just pass lower index, lower residue. Then you'll pass in upper index, upper residue. Then I can remove all of this. Or remove this, I guess. And that might actually be all I can remove. Now this is returning mob1. So I want mob to be this OpenGL object. Then I'll do mob pointwise become partial. The eyeball. Then I have to get the lower and the upper t values. which will be these, the curve index and the t-values. So this will be intersection t-values at 0, and then intersection t-values at 0 at 1. This should be the index, this should be the residue. And then self.add mob, a residue. And then self.add mob. And I'll probably have to move it. And I have zero faith that this will work. Yeah, something broke. Maybe there's a more ergonomic library with shape primitives you can pick up off the shelf. Well, there probably is. That's probably true. But Grant wrote everything by hand already. Like pretty much everything that there's already a library for. He's probably written by hand already. And so as a result, we have to write a lot of this code by hand because there aren't that many APIs that interface on that low of a level. I think I'm just gonna ignore these sanity checks. Respect that. Respect is a way to put it. For a lot of it, he said he just wants to learn a lot. And he did that even to the detriment of the library. So we have to clean up a lot of work. We have a lot to clean up, yeah, behind him. Oh, well. This would be if... I'm just going to take out this check. I don't want this. Wait, why is it still there? How did that happen? Oh, I want this pointwise become partial. Oh, I just called it wrong. This should be pointwise become partial. Like this. Just avoiding saying anything. That's fair. What is still wrong with this? Upper index, upper residue. Are these being passed right here? Mob 1, mob 2. Lower in... Oh, there's a lower. Lower index, lower residue, upper index, upper residue.